Okay, let's work on problem 1227 together. This is a multi-step problem that's going to require us to use probably the easiest method to use Excel to calculate this, and I'll show you how to do that. Maker's depreciation and net present value. The Summit Petroleum Corporation will purchase an asset that qualifies for 3-year maker's depreciation. The cost is $160,000 and the asset will provide the following stream of earnings before depreciation and taxes for the next 4 years. The firm's in the 35% tax bracket and has an 8% cost of capital should it purchase the asset. Use the net present value method. So the first thing we need to do is calculate the effect of depreciation on this business's, investment's cash flow, and to determine its final cash flow based on depreciation and the effect of taxes on earnings. So the first step is we're given some information here. All right, the amount that we're investing is $160,000. That forms the base of the asset that we will be depreciating. All right. And it qualifies for 3-year maker's depreciation. There's a table, table 1212, it's on page 401 of chapter 12, and that gives you your depreciation rates per year for makers. 3-year makers rates, first year is 0.333, the second year is 0.445, third year is 0.148, and the fourth year is 0.074. All right, that would equate to 100% depreciation on the original base every year. All right, so we're going to go ahead and copy that down. And now we can calculate what annual depreciation would be just simply by multiplying the base times its depreciation rate for each year. Okay, and I will copy that formula down. So now we know what our annual depreciation is. And for each of these years, we can move that number down into our next calculation here. Annual depreciation for each year. And we'll use that down here as well, but we'll talk about that in a minute. Now, they gave us in the problem each year, year 1 through year 4, the stream of earnings before depreciation and taxes. So we're going to put that on our spreadsheet here. Earnings before depreciation and taxes. First year, $70,000. The second year is $85,000. Third year is $42,000, and the fourth year is $40,000. All right, so what that does is that this calculation right here will give us the earnings before taxes so that we can calculate the tax effect on this investment. So what we'll want to do is take earnings before depreciation and taxes and subtract depreciation to come up with our taxable earnings, or earnings before taxes. So we'll copy that as well over that formula. All right, and then to calculate taxes, we're given some other information. The firm is in a 35% tax bracket. So I'll multiply our taxable earnings by 35%, or 0.35, to come up with the amount of taxes we'll have to pay on these earnings from this investment. All right, so now earnings after taxes. See, taxes are a negative cash flow, right? But depreciation isn't a negative cash flow. That doesn't have anything to do with cash flow. So what we're trying to determine here, after we're all said and done, is of these earnings that we have, what effect will that have on cash flow? All right, so earnings after taxes. Earnings after taxes, you can see here, are $10,868, but we're going to add back that depreciation because depreciation is just has a tax consequence. It has no cash consequence. All right, so we're going to add that depreciation back to determine what our actual cash flows are for this investment. So we take our earnings after taxes and add back our depreciation, and that tells us for each year that we have this investment what our cash flows are. All right, so the first year cash flow is $64,148. The second is $80,170. The third is $35,588, and the fourth is $31,444. Now that we have our cash flow numbers, you know what we're going to do next. We're going to get our calculators ready. Okay, because what we're trying to do, it says use the net present value method to determine whether we should purchase this asset. So I'm going to turn my calculators on, and if you recall, we're going to be pushing the CEC button first. CEC button, that clears everything out. All right, and then we're going to type the second button and the CEC button, and that will clear out everything. Once we do have to push first the cash flow button. Okay, so push the cash flow button first, and then second CEC, and that'll clear all of our cash flow information out. And now we're ready to enter some data into our calculators. So we start with CFO. If you remember, CFO right now should show on your calculator as 0.00, but our initial investment, our project, is $160,000. So in this column we'll enter negative $160,000. Okay, so 160,000 is what I'm entering in my calculator, and then the plus minus button, and then enter. So I've just programmed that. Now arrow down. I'm going to arrow down, and I have CO1. CO1 is going to be my first year cash flow at $64,148. So I'm going to type $64,148 into my calculator. $64,148 CO1, and I'm going to enter and then arrow down. Enter. Arrow down. FO1 we're going to leave at 1. We're going to leave at 1, and we're just going to arrow down. And we're going to repeat this process here for CO2. CO2 is going to be 80,170. Enter. Arrow down. FO2 is 1, so we arrow down. CO3 will be 35,588. Enter, and then arrow down. FO3 is 1, so we can arrow down. CO4 is 30,144, and we're going to push enter and arrow down. So once we have all of our cash flow numbers entered, CO1, CO2, CO3, CO4, FO1, FO2, FO3, and FO4, we're ready to compute net present value. So now we're going to push the NPV button. So go ahead and do that. And you'll see the very first thing we see is I equals. And what does the problem say? The problem says that we have an 8% cost of capital. So we will type 8 into that number, into that category, and enter. Okay. And then we're going to arrow down. And now what we see is NPV. And that's where we compute. Push the compute button. All right, and our answer ends up a positive 18,536.79. And remember, if our net present value is positive, that means that this project is earning more than our expected required interest rate, which means we should do this investment. We should go ahead and invest in this project.